Breaking news. People from around the world are flocking to see this historic discovery in person. Folks are baffled by this unexplainable, unidentifiable alien monster that has landed here on Earth. We have little to no details on this creature's purpose or appearance, but it seems to be welcoming people in with the allure of tarot readings. With the recent developments in radio communications and technology, the governments of the world are cautiously questioning the reach of our broadcast signals. Could this have attracted the attention of this mysterious creature? Or are we simply at the hands of fate? Stay tuned as we unravel the mysteries of what the world has come to name the mysterious, the remarkable, the amazing Interstellar Fortune Teller.
Now I invite you to step right up.
My name is Kyle Curry.
My name is Jason Ha.
My name is Margaret Jennings.
My name is Paul Kelly.
My name is Iris Quiñones Gonzalez.
My name is Sarah Warmouth.
And our advisor is Joshua Kaplan.
The Interstellar Fortune Teller, or IFT for short, is a project based in the themed entertainment industry that has taken inspiration from past advancements in animatronic technology from pioneers such as Garner Holt, Disney Imagineering, and Jim Henson. As a team, the creative vision for an intergalactic alien creature with the ability to give tarot card readings became our foundational design goal. To better define this idea, the team's mission statement was created as follows: to design and manufacture a physical alien hand. This hand will have hand and eye movements, express a personality, and exist within a simulated space. This system will be modular to allow for portability. The guest will have an interactive, narrative-based experience where a fortune is delivered to the guest in some capacity.
After drafting our initial requirements and objectives, the team began extensive research on mechanical and electrical systems that could achieve the desired motion output and interactive features. We were motivated as a team to stay focused on fulfilling these requirements due to our personal interest in theme park engineering and the advancement of student-led projects that incorporate theatrical elements in storytelling. As planning continued, the scope slowly became larger, with goals and ideas stretching as far as custom silicone molding over the robotic pieces. In order to adhere to the given timeline and budget, however, priority was assigned to systems and goals specifically mentioned in the requirements and mission statement that would allow our original idea to come to fruition.
Each member generated a concept sketch and proof of concept to demonstrate a flexible finger that adhered to certain degrees of freedom. Both jointed and unjointed finger systems were studied. Although both had benefits, the jointed finger system allowed for better repeatability and reliability. Once the concepts were evaluated and voted upon, the finalized design was detailed in SolidWorks and 3D printed to final specifications. Kinematic analysis was conducted to prove the mobility of the system and determine the force needed to flex the finger without breakage.
Research was also conducted to determine the best motor and motor sizing for the animatronic with respect to the enclosure it would be placed in. A particular area of concern was the rotational freedom for the eye. Pitch and yaw movements are achieved using microservos retrofitted into a 3D printed chassis. This system also incorporated fixtures for the 3 fingers attached to the top surface. For manufacturing, UV reactive filament was used to print these components. This causes the IFT to have an ethereal glow in the UV lit space. Assembly for the system required designing and printing the filament using CAD models while securing the servos, springs, and wires inside the printed pieces.
The second essential system to the IFT is the user interface that allows guests to activate the card readings and advance the experience's robotic animations and lighting cues. To achieve this, a dedicated web server was created using Python Flask, while HTML, CSS styling, and JavaScript allowed for the creation of an interactive touchscreen. One of the most prevalent problems our team faced during the design and fabrication of the IFT was the application of robotic code in tandem with the user interface. Having automatic animation sequences fire when guests interact with the touchscreen required the code to both visually display the randomized card readings to the guests and communicate with the Arduino microcontroller to initiate the next set of animations. After attempting to create a web application using HTML and auto-updating web pages, we shift to Python, which hosts a server called Flask, which allows us to set web page buttons as inputs for activating the next animation code sequence. Overcoming this challenge proved our team's capability to adapt on the fly and design around unexpected roadblocks without compromising project requirements.
The final version of the user interface visually displays each card reading along with subtitled dialogue and recorded voice audio for the animatronic. On the back end, an Arduino microcontroller and the created Python code communicates which emotion animation to play. To fulfill the requirement of providing the guest with a take-home memento from the experience, an email will be sent to the guest containing their unique tarot card reading. The tablet displaying the user interface will be affixed to a music stand and placed next to the guests entering the enclosure. The IFT animatronic will be several feet away from the guest, so the only necessary physical interaction will be the guest using the tablet to advance the encounter.
The final system needed to complete the experience is the animation performed by the hand-eye assembly and Stewart platform. To accomplish automation in our animatronic, a newer software to the market, Botango, was researched and introduced. Botango allows for the modeling, animation, creation, and export of motor control all in a single workspace. This perfectly aligns with the team's need. A model of the hand-eye system was created in Botango with the proper microservers, placement, keyframes, animations, resulted in smoother animations to convey unique emotions to the guests as the cards are being read. A similar process was followed to create the floating motion of the Stewart platform. While testing the capability of the software, we communicated with our stakeholders, which comprises of our team, an assigned advisor, and the UCF CCS department. They provided feedback on the ability for our microcontrollers to accept the Botango output and code, and cautioned the team to have backup solutions in case of system code rejection. Our team processed this feedback by weighing the pros and cons of using Botango in relation to the available time left, remaining budget, and team expertise in computer science.
In order to connect the mechanical and electrical subsystems, wires were routed through a hole in the cart surface down to the control box. The control box housed the motor drivers and microcontrollers dedicated to operating the animatronic.
In the final manufacturing and assembly stages of the project, our team had the opportunity to learn valuable lessons regarding resource management and redesign procedures. Working with outside vendors and manufacturing shops demonstrated to our team the importance of communication on a technical and interpersonal level. When working on a project in the themed entertainment industry, many teams involved in one project have wildly varying schedules, so respecting the availability and expertise of all involved will yield the best results with the least amount of stress. This lesson carries over into our future work, where teams will be even larger with more complex requirements, so gaining this experience and knowledge so early in our careers is actually extremely beneficial.
Fulfilling the requirements our team created at the beginning of the project involved testing with our main stakeholders. Those were the IF team, the general public, and the themed entertainment industry. Entertaining an audience and engaging our users in a unique experience provides confirmation that our goals from the beginning were satisfied. To test our systems, the enclosure is built to be a modular setup with the ability to set up and break down quickly in most locations. Guests can experience the IFT one at a time as our team manages the queue outside the enclosure.
The IFT combines several engineering design principles to challenge our team in both the technical and managerial skill sets. Our greatest motivation to complete the project within the budget and time frame was the satisfaction our team would feel seeing guests light up with excitement and intrigue at a student-developed, student-manufactured, themed entertainment experience. The IFT also paves the way for engineering students in the future to feel empowered to attempt a senior design project based on creative storytelling with the use of state-of-the-art interactive technologies in a smaller, hobbyist scale.
If the team were to proceed with redesigns in the future, our team will focus on increasing guest capacity per hour and enhancing the visual aspects of our enclosure and lighting setups. We believe this project has increased our engineering skill set and our imagination. We thank you for tuning into our presentation and look forward to bringing the IFT to life in front of you soon.
Till next time, traveler.